Today we're talking about scatter plots and line of fit. A scatter plot is a graph where there are just points on the graph. There is no line connecting the points. And then we'll talk about line of fit here in a little bit. But scatter plots have a certain correlation. There's either positive, negative, or no correlation. So if we look at this first graph, as we go left to right, my dots go up, which means this is a positive correlation. For the second graph, as my dots, or as my graph goes left to right, my dots go down. So this is a negative correlation. And then the last one seems to be just random dots. So this is no correlation. Okay. And then line of fit is a line that we are going to draw that gets as close to the points as possible. It's not going to be playing connect the dots, so we're not connecting every single dot. We're just going to make a line that's close to my dots. So we're going to see a couple of examples, and these examples that we're about to look at are a lot like a question that was on the 8th grade I-STEP for a couple of years. So example 1, we're going to be asked to do quite a few things. First, we're going to draw our line. Then we're going to write an equation, and then we're going to say what the slope and y-intercept represent. So when I make my line, I like to try to pick a y-intercept that's as close to a real dot as possible. So that one's pretty easy. You just start at 5,000, and we're just going to make our line so it's as close to the dots as possible. Your line and your equation might be different than mine, and that's okay. So I'm going to say that's pretty close. So it doesn't actually touch a lot. This line goes through the points. So it's just kind of in the middle. So to write my equation, the y-intercept is the easiest thing to find. So here my y-intercept is 5,000. Then the slope, just pick 2 points. This part's the trickiest part of this, I think. So I'm going to pick this point and maybe that point. So if you don't have 2 perfect points, just estimate. So here it looks like I went up 1,000, and then I went over 2,000 to 2002, so I went over 2. And that can be simplified to 500. So when I write my equation, it's going to be y equals 500x plus 5,000. And then I need to say what my slope and my y-intercept mean. So start off with the slope. For the slope, I think it's easiest to look at the fraction slope that you had. So my top number was 1,000, which is right here. So that was 1,000 data. I don't know what data they're talking about, but we're just going to use what they told me. For every 1,000 data, and then my denominator was 2. So if I look, that was 2 years. So for every 1,000 data, there's 2 years. So any way to word that so that you're talking about 1,000 data in 2 years. Then your y-intercept. So my y-intercept is right here. So that's 5,000 data. So the data was 5,000 and 2,000. So I just knew it was 2,000 because if I go down, it's 2,000. So for the y-intercept, you just want to match up your what does this number mean and where does it match up to on my x-axis. Okay, going down to the second example. So again, I like to try to pick a y-intercept that's going to match up pretty nicely with my line. So I'm going to start at 36. If you start a little lower, that's perfectly fine. Just estimate what that number is. So I'm going to start here, And that looks like maybe there. Okay. So here my B was 36. My M, my slope, I'm going to use this point, and it looks like this point matches up. There wasn't a real data point there, like the few points that they gave me, that wasn't one of them, but that's okay. I care about more about my line, and my line does look to match up with 31 and 35. So my slope, I'm going to say it went down 1, so that's negative 1, over 30 to 31, so that's 1. And that can be simplified to negative 1. Okay, so your equation could be negative 1x plus 36. You could also write just negative x plus 36. Then we need to say what these mean. So the slope, my numerator was negative 1, so that's down 1 here. And if I look at what my y-axis says, it says female prof, I don't know if they're not professional or professor, I don't know. So female salary, and it says 1K per year, so that's 1,000 per year. So since that was a negative 1, that means the female salary decreased, since it was negative, by, since it was 1 and it says 1K, it decreased by $1,000 per year. No, just $1,000. And then if I look at the denominator, that was 1 as well, but if I look at my x-axis, that was the male salary. So the female salary decreased by $1,000, and the male in salary since that was a positive 1 in my denominator, that's an increase. So the male salary increased by 1,000. So you just need to look, what are my labels and what were the numbers that went with it. So it was down 1, so that's negative 1, but since it's K, we know that's negative $1,000. And then over a positive 1, so that was a positive 1,000 for the male. So it looks like as the females make less money, the males are making more money, which doesn't make sense. And let's look at the y-intercept. The y-intercept was 36. So we could say the female salary was 36, so that's $36,000, when the male salary was, and if I look down, that went to 30, so it was 30,000. So the women, it looks like they start off making more, but then as time goes by, the men are going to be making more, which is kind of weird, but whatever. If you have any questions, please let me know. But again, remember on the last two examples, if your line is different than mine, that's okay. As long as you have a good line that goes close to your points, and you have a reasonable y-intercept and a reasonable slope and a reasonable explanation for what those mean, I'm happy. So if your answer doesn't look like mine, that is perfectly fine. Just make sure your answer makes sense.